In a baseball game, somebody's running towards first base at a rate of 12
What we
feet
want to
per
find
second.
here is at what rate is the distance between the runner and second base changing when he's 80 feet from first base. Since this is related rates, it's best to use the method of Dretz. Not those, but these. Set up a diagram, find your rates, to get an equation, take the derivative, and substitute. I actually found my rates and my values first.
Here I'm just creating a diagram to represent the problem that I'm doing. Really, I'm just supposed to be concerned about the runner, the first base, and the second base. I know that the distance between all the bases is 90 feet each. The runner should be somewhere between home plate and first base, and the runner is 80 feet away from first base, even though it's not included in the diagram because I forgot. The distance between second base and the runner is labeled as S, and that then creates a right triangle. As briefly mentioned before, the distance between home plate and the runner is labeled as X, and the distance between the runner and first base is 80 feet, but it's labeled as 90 minus X because it's basically the same thing. Here I'm setting up my equation with the parts that I'm actually concerned with using the Pythagorean theorem. I'm using the distance between first base, second base, distance between the runner and first base, and the distance between the second base and the runner. After I have my equation, I will go to the second D of Dretz, which is derivatives. But I'm deriving with respect to time, so I will have to do implicit differentiation, or in other words, to do lots of chain rule. I know that every single one of you see the flying 2. That's because it's supposed to say parentheses 90 minus x parentheses squared, not x squared.
For any of you that do not remember how to do chain rule, we got you.
So, what is chain rule? Chain rule is a way of solving complicated derivatives. You use chain rule when you have a function inside another, better known as a composition. You take the derivative of the outside function, you keep the inside, and then you multiply it times the derivative of the inside. A way of thinking of it is you have parents and a baby. You take the derivative of a parent, you keep the baby, and then you multiply it times the derivative of the baby. That is chain rule.
Thank you, Michael, for showing us what the chain rule is. Let's move on.
The derivative of s squared with respect to t is 2s times ds dt. The derivative of a constant is 0, so plus the derivative of 90 minus x all squared is 2 90 minus x times the derivative of negative x with respect to t, which is negative dx dt. I moved the 2 from the left to the right side of the equation. I substituted them 90 minus x, actually 80, because the distance between the runner and the first base. And I substituted that dx dt is 12, negative 12 because of the negative. Now I have s and ds dt to solve for, but ds dt comes at the end. Ds dt is basically the answer. So S I find by using what I had before, which was the Pythagorean theorem. And since Mike was better recording, I just wrote it on the screen. Yeah, very unfortunate cases. I also decided to cancel out the 2's to make my life easier later on. You can't see because I have a big head that I actually decided to move S to the other side by dividing it. And now I have that the SDT is equal to negative 80 times 12 over the radical of 90 squared plus 80 squared. Even though I didn't show all the math, you basically just multiply 80 times 12 and just do the bottom part, the denominator, and you should get that the distance between the runner and the second base is changing at a rate of
16.464 feet per second.